Okay, good evening everyone. Welcome to a nice late spring evening in the Death Valley region of California. I'm Mike Jerry and we're going to see some galaxies tonight. Galaxies galore, I like to call it. So yeah, we've got some really nice weather, a little bit of a breeze here and there you may hear in the microphone, but overall, and I still have a little bit of that very dry cough, just the lingering cough from my cold that I had a few weeks ago. It's just this one little part that won't seem to go away. So, okay, well, let me start off the way I should start off here, which is send the test pattern away, and let's bring up my scope and show you what I'm using for a telescope. And so tonight's going to be an 8-inch Celestron Schmidt Cassegrain telescope with a 0.63 reducer on the back and 183 color camera from ZWO on the back of that, and that's going to be showing us the galaxies tonight. And all of it's riding on an AM5 strain wave mount. And on my spare no expense cinder block pier, and I'm sitting at a table behind all this talking to you. So that's what we're looking at here. I'm going to dismiss this. Okay, so I guess we're good. Good. Yeah, all right. So that is what is going to be bringing us the pictures tonight. And so let's pull up, where is my Stellarium? Okay, there we are. And at the moment we're on Capella, because that's the star I use to focus with. What am I looking for? SharpCap. There it is. There's our Capella. So tonight we're going to be looking at a bunch of galaxies. And they're all over here. Well, I guess I am. Oh, yeah, I thought they were going to be further along, but I guess they are still on the east side. Well, there's some pretty nice ones here on the west side, so let's try taking a look at some of these here. And we'll start with NGC 3198, why not? There's a pretty good one there. Cigar M82. Well, we can look at M82 and 81 first. Let's do that. Okay. Let's zip up and take a look at M82, the cigar galaxy. Alrighty. Let me get in here and make sure I'm centered on it. And then we will plate solve to make sure our camera is centered on it. That should bring us right into the middle, and there it is right there. And then we can start some images. Okay, we'll reset all these things. Alright. Looks pretty good. Now we'll do M81 after this, which is always one of my favorites. Okay, and let's get into our Wikipedia. 82. Copy that. Messier 82, or the Cigar Galaxy, it's about 12 million light years away, so this is one of our more local neighbors. And all right, Let's get our first image of it here. Make sure our colors are on. There we are. Yeah, that's pretty good. Oh, and I forgot to put my flats on. Let's get the flats on there to even off the lighting a little bit, which I believe is that one. $12 million light years away. It's the second largest member of the M81 group, with M81 obviously being the biggest, and we'll look at that next. It has a diameter of about 40,000 light years, which is quite a bit smaller than the Milky Way, but yet it is 5 times brighter, 5 times more luminous. And a lot of people have get some great color out of this. I never seem to be able to get great color, but this is very red in here, and there's even some jets going off perpendicular here, which I also don't usually seem to be able to acquire. But I do get some decent detail in it. Good evening, Daryl from East Texas. Thanks for stopping in. I can put my target name up here. Five times more luminous than the Milky Way, even though it's a lot smaller. It's about 40,000 light years across, whereas the Milky Way is about 120. So it's 1/3 the size and 5 times more luminous. Its central region is about 100 times more luminous. The starburst activity is thought to have been triggered by interaction with neighboring galaxy M81. So basically, because it is interacting with its neighboring galaxy, that creates a lot of energy. It creates a lot of star formation, and it's a high energy, hot kind of galaxy. Let me start the music here too. There we are. As it's one of the closest starburst galaxies, sorry about that, as it's one of the closest starburst galaxies to Earth, it's a prototypical example of the galaxy type. A few supernovas were discovered in it. Etc., etc. Discovered by Johann Hilaire Bode in 1774. Which is why it's also called Bode's Galaxy. So we're basically looking at this edge on, which is why it looks like a cigar, and it's called the Cigar Galaxy. Lovebug Soup asks, will this live be saved? Yes. All YouTube live streams, I think all YouTube live streams, certainly all of my YouTube live streams, are just become regular YouTube videos once they're completed. So yes, even if you can only see the first little bit of this, you can come back tomorrow, next week, next month, or next year and pick it up and see the rest of it. So it will be here for a while. Alright, let's darken you down a little bit. That background sky a little darker. I don't want to blow it out too much, because then we lose the texture. But it is one of the more interesting looking galaxies. There's a lot of really interesting looking ones. But this one is just, we're looking at it edge on, but there's no clear dust lanes around the edges. It all's kind of bunched in the middle. So it's definitely an interesting looking thing. I bet it's a nice bright galaxy, so we won't have to spend a whole lot of time on it. And then we'll do M81 here right next door, with which it is interacting. They're pretty close together, and are creating a lot of high energy activity in each other. So they're pretty bright. 'Gotta stretch that a little bit more to show you guys a little bit more of it, but like I said, the brighter I make it, the more it washes out, so I want to be careful not to do it too much. 'This it was believed to be an irregular galaxy. In 2005, however, two symmetric spiral arms were discovered in the near-infrared images of M82. The arms were detected by subtracting an asymmetric exponential disk from the near-infrared images. They were missed earlier due to M82's high disk surface brightness and the nearly edge-on view we have of the galaxy. In 2005, the Hubble Space Telescope revealed 197 young, massive clusters in the starburst core. The average mass of these clusters is around 200,000 solar masses. Hence, the starburst core is very energetic and high-density environment. Throughout the galaxy's center, young stars are being born 10 times faster than they are inside the entire Milky Way galaxy. Milky Way is a pretty mellow galaxy in comparison to the starburst activity in M82. I think it's just stretched a little too much. Just makes it a little too blown out. There's 10 images. I think it came out pretty good. And now we will go to M81 next. So let's go to 81 next, which is right next door. Right here. Over there real quick. There we are. Yeah, see, it's going to fill our field of view very nicely, and there's the core right there already. So let's jump on that bad boy right now. Come on. All right. M81 is next. One of my faves. It's a great looking galaxy. Alright. 81. Go. M81, or Bortle's Galaxy, is a grand design spiral about 12 million light years away. It has a diameter of about 96,000 light years, so much closer to the size of the Milky Way's 120. Because of its relative proximity to the Milky Way, its large size and active galactic nucleus, which harbors a 70 million solar mass supermassive black hole, M81 has been studied extensively by professional astronomers. Okay, yeah, there we go. There's a nice start. It's a beauty. The nice symmetric trailing arms, and you've got dark dust lanes in it. It's a very nice looking galaxy. I'll get a few subs on this. Discovered by Johann Erler Bortle on 31 December 1774. In 1779, Pierre Marchand and Charles Messier re-identified Bortle's object, hence listed it in the Messier catalog. Apparent magnitude due to its distance means it requires a good night sky and only rises very briefly and extremely low at a southern limit from Earth's surface. They're good binocular targets. This galaxy, they say that can actually be seen naked eye under very dark skies, but I got my doubts. My understanding is there's only one extragalactic object that we can see naked eye, which means there's only one object we can see that's outside the Milky Way with our naked eye, and that is the Andromeda Galaxy. Some people claim they can see this one, but I don't know. I don't know about that. With this one we can stretch a bit more to pick out those outer arms. We may let this go a couple of more minutes too, to let it fill in a bit. Fill in a little better. What's it called? This one is called Messier 81, M81, or Bortle's Galaxy. The galaxy is best observed during April. Well, I guess we got it just in time. It's nice and high in the sky. meridian. 3198. 3179. And there's the Leo Trio down here. The Leo Trio is actually back there. But these are pretty cool too. Tiger's Eye. That's a good one. Tiger's Eye, and this one is, yeah. We'll do the Tiger's Eye next. The Tiger's Eye is a good one. LeBug asks, what is the telescope diameter? This is an 8-inch Schmidt-Cassegrain telescope. So 200 millimeters or 8 inches. And we're currently at f6. Right about exactly f6. So about 1200 millimeters of focal length in a 200 millimeter aperture scope. Starting to fill in now some of the details, some of the cloudy, clumpy nature of the star-forming regions are showing up a bit. This is just such a pretty one. Two nice concentric spiral arms. A nice core. Some dust lanes, a little bit of dust lane features in here. It's a really pretty one. And at only 12 million light years away, it's one of our local neighbors. So, not as close as Andromeda, which is only like 2.5 million, or Triangulum, which is only about a little under 3 million. It's a bit further away than that, but still in galactic terms, 12 million light years is pretty darn close. Some of the galaxies we'll see tonight will be dozens, if not hundreds, of millions of light years away. Any other cool facts? Well, I don't think so. I think those are kind of the highlights. Let's see if there's anything else in here. Again, you can see it with a binocular or a small telescope. Telescopes with apertures of 8 inches or larger are needed to distinguish structures in the galaxy. Unless you're using a camera, then you can get away with even smaller. It has over between 200 and 250 globular clusters. I think the Milky Way only has about 150, so I think it has more. In the center of M81, there is a supermassive black hole with a mass of about 70 million solar masses. It's active, having an accretion disk and a one-sided relativistic jet. The observation also demonstrates that there may exist a second supermassive black hole that orbits the primary supermassive black hole with a period of around 30 years. The mass of the secondary supermassive black hole is estimated at 1/10 of the primary. Orbiting supermassive black holes. Gravitational interactions of M81 with M82 have stripped hydrogen gas away from all three galaxies, forming gaseous filamentary structures in the group. Huh. Pretty cool. Alright, well, we'll get to the end of our 12th minute here, and then we'll go and do the tiger's eye. Next. There we are. M81, always one of my favorites. Very cool galaxy. Okay, so now we're going to do the tiger's eye. Right here at the very outskirts of the very front of Ursa Major. Got the tiger's eye. Okay. So yeah, there it is right there. Okay, so let's get on the tiger's eye. The original massive black hole was about 70 million solar masses. So they were saying that the orbiting one is only about 7. Only 7 million solar masses, which means the mass of 7 million of our suns. The other one being 70 million solar masses. So lots of gravity. That's a massive gravity well. And you see 2841. And GC 2841. Okay. 2841 is an unbarred spiral galaxy. It was discovered by William Herschel in 1788. Initially thought to be about 30 million light years distant, the 2001 Hubble Space Telescope survey of the galaxy's Cepheid variables determined its distance to be approximately 46 million light years. So, a lot further away than thought. This is the prototype for the flocculent spiral galaxy, a type of spiral galaxy whose arms are patchy and discontinuous. The morphological class is SAA, indicating a spiral galaxy with no central bar and very tightly wound arms. There is no grand design structure visible in the optical band, unlike what we saw with M81, which has a nice grand design structure, although some inner spiral arms can be seen in the near infrared. The properties are similar to those of the Andromeda Galaxy. It's home to a large population of the young blue stars and a few hydrogen beta regions. Its disk of stars can be traced out to a radius of about 228,000 light years. Well, hello, India. Thank you for stopping in. You've traveled a long way to get here. This is the Tiger's Eye Galaxy. That we're looking at. See how we're doing here. Doing pretty good on that. The rotational behavior of the galaxy suggests there is a massive nuclear bulge. A prominent molecular ring is orbiting at a radius of 7 to 20,000 light years, which is providing a star-forming region of gas and dust. The nucleus appears to be decoupled, and there's a counter-rotating element of stars and gas in the outer parts of the nucleus, suggesting a recent interaction with a smaller galaxy. Cool. Not connected to guiding. Why is it claiming it's not connected to guiding? happened the other night, too. Claimed it's not connected to guiding when it's clearly connected to guiding. PHD2. Tethering. That's all correct. That's all correct. Well, I'm supposed to be dithering. Guiding application, only stack, automatically dither, only stack when every 2 frames, reduce exposure, but it's claiming not connected to guiding. I don't understand why it's claiming it's not connected to guiding. Radius of how many degrees? I don't recall saying. It's about 150,000 light years in diameter, if that's what you're asking, so it would be a radius of about 75,000, if that answers your question. Let's see what we gotta do next. I think we can go down and do 3198. The little pinwheel. Yeah, let's do the little pinwheel. Okay. So, my tiger's eye. And hello, little pinwheel. Just keep walking our way along the meridian here. Okay, plate solve our way in. Wow, why is it off by 0.8 degrees? That doesn't sound right. Not seeing a galaxy in there either. Hey, Mark. Welcome to the show. Is nobody broadcasting on NSN tonight? Alright, let's see if I've got a galaxy in this picture. Supposedly the little pinwheel, but what I saw there wasn't highly encouraging. And it certainly shouldn't have been off by almost an entire degree on that such a short slew. So I'm doubtful. No, it's right there. So he's in the right spot. I don't know why the slew is off by so much, but whatever. Oh, no one's on yet, huh? I got solar going. Ready to clear a tree. A tree you haven't cut down yet, or is this a neighbor's tree that you haven't cut down yet? This one's kind of a pretty one with a contrasting yellow star right next door. Alright, let's see. So we are on 3180, the little pinwheel. 3180. Why just 3180? Why does Wikipedia not have an entry for it? That seems odd. That's interesting. Wikipedia calls it 3184. Well, somebody's got a wrong number. Anyway, the little pinwheel is an unbarred spiral galaxy approximately 40 million light years away. And its name comes from resemblance to the Pinwheel galaxy. It was discovered on 18 March 1787 by William Herschel. It has two hydrogen beta regions that each have their own NGC numbers, one of which is 3180, which is Stellarium's name for the whole object. So, don't know what that's about. Why just saying not connected to guiding? I must be missing a step somewhere. I don't get why this is doing this. It's claiming it's not connected to guiding when it is connected to guiding. Let's brighten this up a little bit. Brighten it up a little bit more. Mine, when the sun moved north and run out of USB length. Yeah, this is NGC 3180 according to Stellarium, or 3184 according to Wikipedia. So Well, thanks, Lovebug. Thank you for being here. It's always nice to have an appreciative audience, so thanks for stopping by. While this one's loading, let's see what we can do next here. I think we'll head down to Leo. No, that's not what I'm trying to get. Why won't you let me click the one I want to click? Right there. Leo 2 dwarf galaxy. I don't think we're going to do. We will do, well, 95 and 96 are in here. But I don't think I can. Yeah, it's my field of view is a little too small. But wonder if there's some setting in here somewhere that I'm not seeing. Boy, it's slow to respond. So slow to respond. Guiding. That is turned on. Plate solving, polar alignment, guiding, logging. I can get this out of the way so you guys can see that. Continue to see the cameras, hardware. Mount, hardware, filter wheel, focuser, switches, covers, calibration, general, display, blah blah blah. It says it's connected to PhD2. Well, it says it's using it. Claims in here that it is not. Claims in here that it's not connected to guiding. It is a pretty little galaxy, though. Alright, well, there is the little pinwheel galaxy. Let's move on to a twofer. I get M105 and second galaxy. We're gonna get right in the middle of both of them. Actually, it's just gonna be a threefer. Gonna be 3 galaxies in here. Where are you? There you are. Make sure you get into the picture here. Get settled. Then we'll get your plate solved. 1.5 degrees. Why is this thing? Wow. I don't know why it's slewing so far off tonight. It seems to be plate solving just fine, but for some reason not slewing. Don't know. Anyway, in this case, it's going to be Messier 105 and NGC 3384. Okay. An elliptical galaxy in Leo, discovered by William Herschel in 1784. NGC 3384 is a member of the M96 group of galaxies in the constellation Leo that is sometimes referred to as the Leo 1 group. Oh, there's all 3 of them. There's all 3 of them right there. This group also includes the Messier objects M95, M96, and 105. All these objects are conspicuously close to each other in the sky. Yeah, well, we got all of them. Elliptical galaxy. It's a spiral, or at least a disk. This is an interesting looking galaxy there. I think that's 3384 there. Let's lose our annotation. Use our annotation and see. Why are you not showing me what this one is? It's 3373 down there. Okay. 3373. Definitely a bunch of galaxies in there, though.
Thanks for stopping by, Mark. Have a good time with your solar. If I'm still up later, I'll stop by. Good evening, Mike. Thanks for stopping in. We're looking at NGC 3384 and friends here at the moment. .373 is definitely interesting looking. I guess it must be a spiral with some areas of star formation clumping around the edges. Definitely interesting looking galaxy. However, I think we're going to be off to M96 next. That one right there. So let's move on to that one. Move on to that one. Alright. Slew over there. Very short slew. Well, it's an interesting looking galaxy. What is this one? Doesn't even have a name on it. Oh, that's 95. Well, one at a time. That's all we can do. Thanks, Chris. Thanks for stopping in. I like doing galaxies. There's some pretty cool things, especially when you consider how massively large and massively far away they are. $33.51. Yeah, no, but I'm on this one. 3368. $96. Okay, this guy. An intermediate spiral galaxy, 31 million light years away. Oh, yeah, it's got an inner part and it's got an outer part. That looks like another galaxy right there. A little too fuzzy looking to be a star. Yep, it's PGC. That's PGC right there. A few galaxies in this image. It was discovered by French astronomer Pierre Marchand in 1781. After communicating his finding, French astronomer Charles Messier confirmed the finding 4 days later and added it to his catalog of nebulous objects. Finding this object is burdensome with large binoculars. Ideal minimum resolution in a good sky is via a telescope of 10 inches aperture to reveal its 3 by 5 arc-minute halo with a brighter core region. It's a double-barred spiral with a small inner bulge through the core along with an outer bulge. Messier 96 is about the same mass and size as the Milky Way. It's a very asymmetric galaxy. Its dust and gas are unevenly spread throughout its weak spiral arms, and its core is just offset from the midpoint of its extremes. Its arms are also asymmetrical, thought to have been influenced by the gravitational pull of other galaxies within its group. M96 is the brightest galaxy within the M96 group, the rest of which are M95 and 105. To this are added at least 9 other galaxies. Okay, well, you're really starting to be able to see the outer part now. All right. There's 10 minutes on that one. That's a pretty cool looking galaxy. Brighter inner core. A much fainter outer area. With more extended area for stars. Okay. Let's do its neighbor M95. This one's going to be an even more interesting looking one. This one's going to have a lot more features. There it is in the middle. So let's start on that. See, monitor guiding application. It's clearly connected to guiding. It's clearly aware of guiding, and yet claims it's not connected to guiding. I guess I'm going to have to get on the SharpCap forums and report a bug. But, in any event, M95. Which was what I said, 3351. It's a barred spiral, 33 million light years away. Discovered by Pierre Marchand in 1781 and cataloged by Charles Messier 4 days later. It's a barred spiral with arms that are intermediate on the scale from tightly to loosely wound, with an inner ring which surrounds the bar. Yeah, it's kind of cool looking. So the inner ring that surrounds the bar, so just this part here, not the extended outer part, but just the ring that surrounds the bar, is about 70,000 light years across. And then the spiral structure extends outward from there. Okay, so it's about 70,000 light years across. So a little bit more than half the size of the Milky Way. Probably the whole thing is about the size of the Milky Way. Our Milky Way is about 120,000 light years across. Yes, Amelia, it will be saved after the live stream finishes. It will just become a regular YouTube video on my channel. So you can, if you only get to see the first few objects tonight, you can come back tomorrow or next week or next month or next year and see the rest of them. It will be just a regular video in its entirety after I finish tonight. Good evening, John. Thanks for stopping in. We're currently looking at M95. Where shall we go next? Oh. We've done these three. I guess the Leo trio could be next. Pop on over here. I don't think I can get... Might be able to do these two together. 65 and 6, maybe. If I can get a star to click on it. Ooh, there we go. Yeah, maybe. I might be able to do 65 and 6 together. That would be cool. But this is definitely an interesting looking galaxy. In fact, we can zoom in a wee bit more. Really see that bar nice and strong, and then the inner circle, which is about 70,000 light years across, and then the whole outer part. Darken it up a little bit. Maybe lighten that up a little bit. Yeah. Alright. M95. Now let's try 65 and 66 together. See if we can snag both of those guys. And we'll get the Hamburger Galaxy after this. Okay. Plate solve on that. There we go. 0.9, that's better. Alright. Should have both of them in the view. If Stellarium isn't lying to me. Both be in the view. In the meantime, 65, 3623. About 35 million light years away. Discovered by Charles Messier himself. Discovered this one in 1780, along with M66 and NGC 3628, which we're going to see next. Discovered all three of these, and they are the famous Leo trio. So this is two of those famous galaxies, and then we'll look at 3628 next, which is also called the Hamburger Galaxy. And that's a very cool looking galaxy. These guys are pretty nice too, but Looks how the galaxy is low in dust and gas, and there's a little star formation. Although there has been some relatively recently in the arms. The IM65's disk appears slightly warped, and its relatively recent burst of star formation is also suggestive of external disturbance. There's been suggestion that the two other galaxies in the Leo triplet interacted with each other about 800 million years ago. Recent research suggests that all three may have interacted, though much less strongly. Okay, so M65, which is the one down here, yeah? No, 65 is up there. So 65 may have only interacted loosely. But it may have a bar. They're unclear about the bar part of it, but it's a nice disk with a great dust lane in it. And 66 is just really interesting looking. Again, misshapen and asymmetrical, probably due to interaction with the third galaxy in the trio. Which we will see after we get done getting these. Alright, we've got several subs going here, so zoom in a little bit on this. Yeah, definitely a nice looking dust lane there. And they're speculating there may be a bar in there. That it might be a barred spiral, but hard to tell.
Nice sharp core though. And then M66 is an intermediate spiral. So 66 does have a much more pronounced bar structure, which you can see in there, and then kind of loosely wound arms, like one turn on them. It's also 31 million light years away and about 95,000 light years across. So just a bit smaller than the Milky Way. With striking dust lanes and bright star clusters along sweeping spiral arms. And you get some bright, bursty bits in there. Gravitational interaction from its past encounter with NGC 3628, which is the galaxy we're going to see next, has resulted in extremely high central mass concentration. Yeah, definitely some nice detail in this one too. Alright, one final look at 65 and 6. Pretty cool looking galaxies, 30 plus million light years away. And now we'll look at probably the most interesting one in the group, the hamburger. This one's a pretty interesting looking guy. NGC 3628, also known as the Hamburger Galaxy or Sarah's Galaxy. It's an unbarred spiral about 35 million light years away. It's discovered by William Herschel, 1784. And is an approximately 300,000 light year long tidal tail. Along with M65 and 66, it forms the Leo trio, or Leo triplet. A small group of galaxies. Its most conspicuous feature is the broad and obscuring band of dust located along the outer edge of its spiral arms, effectively transecting the galaxy to the view from Earth. Well, there we go. It is a very cool looking galaxy. Due to the presence of an X-shaped bulge visible in multiple wavelengths, it has been argued that it is instead a barred spiral galaxy with the bar seen end on. Simulations have shown that the bars often form in disk galaxies during interactions and mergers, and NGC 3628 is known to be interacting with its two large neighbors. When viewed through a telescope, it's often seen as a dim orb, as it has a relatively low surface brightness for a supposedly famous galaxy. Though when viewed with the larger one, it begins to show off more of its intricate details, such as its prominent dust lane obscuring its core. The name Sarah's Galaxy is thought to refer to poet Sarah Williams, 1837 to 1868. 31 years old. She didn't live long. Most famous for the poem The Old Astronomer. Though my soul may set in darkness, it will rise in perfect light. I have loved the stars too truly to be fearful of the night. One. Sarah Williams, a poet. Alright. The Hamburger Galaxy. So that's the Leo trio. We just did all three of those there. Just a whole gaggle of galaxies coming across at this point. More galaxies than you can shake a stick at. M98. Sure, what the heck. The Hamburger is one of my favorites. It's definitely an interesting looking galaxy. M98. Okay. Make sure we're on it. Alright. We'll do M98 because it's here. NGC number 4192. M98, an intermediate spiral, 44.5 million light years away. Discovered by Pierre Marchand in 1781, along with M99 and 100. It was catalogued by Charles Messier 29 days later, thus the M numbers. It has a blue shift, which means it's getting closer to us. Look at that. A couple other galaxies in the picture. Probably more than a couple even. It is a spiral galaxy that displays mixed barred and non-barred features, with intermediate to tightly wound arms and no ring. It's highly inclined to the line of sight. About 3/4 billion years ago, it may have interacted with Messier 99. Which is right next door. Right here. And we'll get to see that next. 98, 99, and 100. And I think, actually, unless I get a burst of energy here, that may be my last object. I had a very long day today, so I'm not going to be going very late tonight. My last few sessions have been pretty darn long. I've been doing 3 to 3.5 hours. Tonight is definitely going to be a shorter one. I'm pretty tired tonight. But the breeze has just suddenly died down too, and it's just absolutely gorgeous. The little crescent moon has set and the breeze has died off, and it's pretty sweet. And warm too, relatively speaking. Let's see what these other galaxies are. NGC, this actually has an NGC number. Nice. this a satellite or just way further back behind it? Thank you, Mr. Barbarossa. I appreciate the compliment. Do you have any skies tonight, David? Kind of hard to tell from the satellite imagery whether you had some or not. Looks like you had some clouds earlier, but I thought maybe it was going to clear for you. Cool. We've actually had a pretty clear night here tonight. Up until about 15-20 minutes ago, had a little bit of a breeze, so I've been battling that with not such good guiding, but about 15 or 20 minutes ago the breeze just stopped. And now it's just kind of a warm, calm, clear night. It's kind of perfect. So, got a good one here after a while, but it looks like the last one for me for a while, because now it's, I think tomorrow night it's clouds, and then over the weekend we're going to have a big cool off. It's like low 90s here, which is beautiful. Sunday 86, Saturday 86, Sunday 70. So a big cool off blowing in, and of course every time we get a cool off, it literally blows in, so we're going to have a bunch of wind and everything else too. So, yeah, it's interesting spring weather. but we still really haven't had any real heat, knock on wood, because it's certainly going to be coming, but haven't had any yet, so it's been a pretty nice, long, gentle spring. But unfortunately, with that cooler air comes more wind and stuff, so, and clouds. So I haven't been able to be on very much, but and then today was just a busy day, so I'm a little whooped tonight. Not going to go very late, but we'll at least get a few of them in. You can pretty much pick out some of the dust lanes in here. Got a nice dust lane there. Got another one up in there. Almost like a two-tiered spiral arms. You got a sort of two layers to the spiral arms here. Up there and down here. Well, let's see what 100 looks like. Done 98. Oh, I'm sorry, 99 is next. That was 98. Let's see what 99. Virgo cluster pinwheel. Well, okay. We shouldn't need to plate solve. That was a pretty short slew. So this will be 99. Doesn't have a link to 99 in there, okay. 4254. Or 4254 M99 or St. Catherine's Wheel. It's a grand design spiral. Approximately 49 million light years away. Discovered by Pierre Marchand in 1781. And then Charles Messier also included it in his catalog. It's one of the first galaxies in which a spiral pattern was seen. This pattern was first identified by Lord Rosse in the spring of 1846. It is a pure spiral shape with loosely wound arms. It has a peculiar shape with one normal-looking arm and an extended arm that is less tightly wound. A bridge of neutral hydrogen gas links NGZ 4254 with Virgo HI21, a hydrogen alpha region, and a possible dark galaxy. The gravity from the latter may have distorted M99 and drawn out the gas bridge, as the two galaxy-sized objects may have had a close encounter before parting greatly.
also possible that it interacted with NGC 4262 about 300 million years ago. And that may have caused the arm as well. The one extendy arm. Hi Jake, whereabouts in Death Valley? I am about 25 miles southeast of the park border. In the town of Tacoma, California, which is just south of Shoshone. Don't know if you're familiar with the area or if that helps you at all, but I'm not actually down in the valley itself. I'm just outside the national park boundary. Subs in, maybe we can risk a little more of a zoom in. so many of them in here. We'll get back to those another night. I think this will be my last one for tonight. I'm kind of beat, so this will be a little bit shorter of a session than normal, even though the weather is, with the wind dying off, has turned into a perfect evening, but I am just falling asleep here, so we'll do this one more here. So there's 99. One extendy arm. And we'll get 100 in here, and then I will call it a night. And 100 of the blow dryer galaxy. 4, 3, 2, 1. Alright, GC 4321 or Messier 100. Another grand design, intermediate spiral. It's one of the brightest and largest galaxies in the Virgo cluster. It's about 55 million light years away, and about 166,000 light years in diameter, so significantly bigger than our Milky Way. Discovered by Pierre Marchand in 1781, and confirmed by Charles Messier in his catalog. It was one of the first spiral galaxies to be discovered, and listed as one of 14 spiral nebulae by Lord William Parsons of Rosse in 1850. And you see 4323 and 4328 are satellite galaxies of M100. The former is connected with it by a bridge of luminous matter. 4328, I don't know if that's these guys or this guy. Let's let the annotation tell us. Yeah, those two down there. So, a bunch of satellite galaxies it has. What's 4327? Is that another galaxy? No, it's a star. 4327. Why does a star have an NGC number? That's interesting. Stars do not usually have NGC numbers. Huh. Very interesting. This is 4312, a wholly different galaxy. Alright, well, let's keep them all in the picture here. 100. After the discovery of M100 by Marchand, Charles Messier made observations of the galaxy depicting it as a nebula without a star. He pointed out that it was difficult to recognize the nebula because of its faintness. William Herschel was able to identify a bright cluster of stars within the quote-unquote nebula during his observations. His son John expanded the findings in 1833. With the advent of better telescopes, John Herschel was able to see a round, brighter galaxy. However, he also mentioned that it was barely visible through clouds. William Henry Smythe extended the studies of M100, detailing it as a pearly white nebula and pointing out diffuse spots. $55 million light years away. Hi Francisco. No, this is actually M100, Messier 100. So this galaxy is much, much further away. Andromeda is one of the closest galaxies to us, so only about 2.5 million light years away. This one is 55 million light years away. And it's in the constellation of, is it Leo? Coma Berenices. That's Coma Berenices. So, very different one. And it's got a bunch of satellite galaxies here, which is not unlike Andromeda. But, yeah, it's got some satellites here. But it's a pretty galaxy, but it's much bigger and much further away than Andromeda, actually. Yeah, Andromeda would look a lot bigger. And it's this one has some tightly wound arms on it. Andromeda is a much bigger, cloudier galaxy in its center. So, and we also don't see Andromeda face on like this. This one we're seeing almost perfectly face on, whereas Andromeda we kind of see at an angle. So, but because it is so much closer to us, it would be much bigger. Yeah, I mean it would way more than fill my view. This, if I were looking at it with this setup right here, it would probably, I would only see it would fill about 3 times the view of my camera here. You know, my camera right now. That's my field of view, and Andromeda I'd only be able to get the middle third or so of it in this field of view. It's big. Well, this galaxy is actually bigger at almost 170,000 light years across. Andromeda's only about 100 or so, about the same size as the Milky Way. This one's actually significantly bigger, but it's just it's just 25 times further away. And there is M100. And I guess, you know what? I'm going to do one more just for the heck of it. I know I said I was done, but I'm going to do one more anyway just for the heck of it. I'm going to do this little interacting pair here. Do this little interacting pair here, 4302 and its companion, just to kind of have this whole little group done. And this will be my last one for the night. Okay. So this will be another twofer, and these two galaxies are interacting. Yeah, we actually look at Andromeda a bit at an angle. So we're almost looking at it across. Well, we're looking at it across the top of its face. Whereas in 100 we're looking at it almost completely face on. So okay, so this is going to be 4302. 4302. It's an edge-on spiral, located also about 55 million light years away. Discovered by William Herschel in 1784. I guess I should have plate solved it a little bit closer. In fact, I think I'm going to do that. Let's plate solve that into the center a little bit better. Yeah. There we go. That should have us focusing a little better. It means we have to wait another minute, but we'll get a better image. And 1784, classified as a Seyfert galaxy. It has a prominent extended dust lane.
Doesn't really talk about the other galaxy though. 4298 is the other galaxy. Doesn't really talk about it much. One fact I learned recently is when galaxies interact with each other, collide, the matter inside them does actually violently smash with each other because of the sheer size of them. That's absolutely true. Galactic collisions, even though each galaxy has tens of billions, if not hundreds of billions of stars in each one, when they collide, it's extremely rare for any particular star to collide with, from one galaxy to collide with a star from the other galaxy. And the primary reason for that is because, like, look up in our own sky, the massive amount of distance between all the stars means that 99% of all the galaxies, in fact 99.9999% of every galaxy is nothing but space. It's not actual stuff. So when they collide and tear each other apart, really all that's interacting is their gravitic fields. It's just gravity that's doing all that. It's not the collisions of the stars themselves. This definitely does have a nice little dust lane in there. Let's see what 4302 doesn't really talk about. That's 53 million light years away, so this one, the top one here, is a couple of million light years closer to us than 4302 down here. Also discovered by William Herschel. This one talks about interaction with NGC 4302. NGC 4298 appears to form a pair with and appears to interact with NGC 4302 here on the bottom. Evidence for interaction between the two galaxies are that 4298, the top one, exhibits a lopsided asymmetrical distribution of stars, a tidal bridge that connects it to 4302, a prodigious rate of star formation, and a hydrogen alpha tail. However, the tail is also the result of ram pressure. The two galaxies are separated from a projected distance of 36,000 light years. Anyway, so 4298, the write-up of 4298 talks about the interaction between the two. But 4302, the write-up in 4302 doesn't really mention 4298 at all, which is interesting. So this one's a spiral. This top one, excuse me. Yeah, this is definitely going to be my last object. This top one is a flocculent spiral, which means that just the arms are not defined. It's just sort of a loose, spirally, swirly sort of texture. Not really any specifically defined arms.
Thank you for being here, Francisco. Appreciate your appreciation. It's always nice to play to an appreciative audience, so thank you for being here. I do enjoy these objects, and I do enjoy observing them, but presenting them to other people is even more fun, so hopefully I can teach you something and send you to bed with stars in your eyes, I guess. Okay, and there are those two galaxies, 4302 and 4298. I am going to call it a night, guys. Thank you for being here. I appreciate your time, and hopefully you got to see something pretty tonight and got to learn a couple things. So, always a pleasure to have you with me, and thanks for watching. And I will see you next time. Thanks, everybody.